Hi everyone, very good morning to all. Today we are going to study about question number 45, that is how to deal with AC circuit. I mean AC series circuit. Last time we have seen the AC circuit, but that is pure AC circuit, either resistor or capacitor or inductor. But now we are telling like it's like what is the series combination. So the series AC circuit means when two or more elements connected in series, then now when we consider this series circuit, what are all the combinations are possible is the first one is when a resistor is in capacitor in series with capacitor across an AC source, or when a resistor is in series with an inductor LR circuit. So these are the two combinations first. Like when we apply an alternating EMF, let's take V equal to V naught sine omega t, then there must be one alternating current I equal to I naught sine omega t plus or minus phi. Now in case of RC circuit, as capacitor is there, resistance does not cause any phase difference, but capacitance causes lead of current. That's why the current equation will become like I equal to I naught into sine omega t plus pi. In case of RL circuit, I will become I naught into sine omega t minus pi. So inductor causes lead of voltage and capacitor causes lead in current. So this is the general form of alternating current in any series combination, where the amplitude will become, amplitude of the current will become amplitude of voltage by the impedance of the circuit for every series combination. So what is the meaning of impedance is, impedance is the resultant of resistance and in reactance. Here capacitive reactance. And same way here also I naught equal to V naught by Z, where Z is under root R square plus XL square, where XC we have seen as 1 by omega C, XL we have seen as omega L. Also, the formula for phase difference tan pi is reactance by resistance. So that here the phase difference is XL by R. So this is the general formula for amplitude of AC current in the series circuit and the phase difference between voltage and current. And the general formula for power dissipated in any AC circuit, even last time we have seen P equal to V naught I naught by 2 times cos pi, where pi is the phase difference. If you know tan pi value, you can find cos pi value using the Pythagoras theorem. Now similar way, when you consider the series combination, one of the most important combination is LCR in series across an AC source. So V equal to V naught sine omega t, like VL, VC, VR, where V square, the resultant voltage will become under square equal to VR square plus VL minus VC or VC minus VL whole square. So from here, when you consider current equal to I naught sine omega t plus or minus pi, if VL is greater than VC, then voltage leads. If VL is less than VC, then current leads, depends. So where you can take general formula like tan pi equal to XL minus XC by R. If XL is greater than XC, then pi is positive. If XL is less than XC, then pi is negative. So depends. Depending on that, it will come. So this is the general equation for LCR series circuit. But where I naught is V naught by Z, where Z is under root R square plus XL minus XC whole square. And at resonance condition means the amplitude of current becomes maximum, that is at XL equal to XC, where omega naught equal to 1 by root LC. At this frequency, the amplitude becomes maximum and impedance becomes minimum, that is resistance. So that I naught maximum will become V naught by R. So this is the resonance condition in series LCR circuit. So they can ask question based on resonance condition. They can ask a question based on phase difference between current and voltage, whatever it is. So these are all the formulas you have to remember. And one more thing is 99.9% the questions will be asked in such a manner that it's completely formula based, but you have to do lot of calculation. The calculation takes like an important role, especially in AC. Every chapter calculation is important, but in few of the chapters it is very difficult calculation. And AC is one such kind of chapter where calculation always they give big, and where you have to show your calculation skills. You have to do fast and perfection. Let's see few examples based on whatever we have discussed. Now, a 100 ohm resistance is connected in series with a 4 Henry inductor. So inductance is 4 Henry and resistance is 100 ohm. And the voltage across the resistor VR equal to 2 into sine 10 power 3 radian per second. Now they are asking find the expression of circuit current. As both are in series, current must be same. Then current for resistor means voltage by resistance. So that 2 sine 10 power 3 by resistance is 100. Find the inductive reactance. Inductive reactance means XL. XL equal to omega L. I think there must be some here T should be there because the function AC means it must be a function T only. I think the T is missing. You please correct it. So XL equal to omega L. Omega is the coefficient of time. That is, they have given as 10 power 3. L is inductance, that is 4. And derive an expression for the voltage across the inductor. So here, when you have the current equation, then voltage equation means voltage and current for the inductor when you compare. So voltage across the inductor will become like V naught into sine omega t plus pi because voltage leads. So that pi is, how do we find it? Oh, they are asking just only voltage across inductor, not the net voltage. So the pi will become how much? Pi by 2. Now sin pi by 2 plus theta, what it will become? Cos theta. So VL equal to V naught cos omega t, where V naught is the maximum voltage, that is IXL. And how to find V naught is, V naught value is I into XL, I mean I naught into XL. So this way you can find, see when you consider this question, everywhere it is calculation based. Find the expression of circuit current. That is direct question. But find the inductive reactance, direct formula, simple calculation. Derive an expression for the voltage across the inductor. So when you consider voltage across resistor and voltage across inductor, they differ by a phase difference of 90 degrees. That's why I have taken phase difference as 90. And you have to calculate V naught value. Next, a 100 microfarad capacitor in series with a 40 ohm. So the capacitance is 100 microfarad is in series with a 40 ohm resistance. So the resistance is 40 ohm. Is connected to 110 volt 60 hertz supply. That means VRMS is 110 volt and frequency is 60 hertz. So what is the maximum current in the circuit? What is the maximum current in the circuit? That is I naught value. So I naught value is V naught by Z. Now VRMS means V naught by root 2. So V naught equal to root 2 times VRMS. That means 110 root 2. V naught is there. Now Z value is under root R square plus XC square, where XC is 1 by omega C, where omega is 2 pi F into C. C value given, F value given. Now first you have to find XC, then you have to substitute here. Then you will get the Z value, then you will get I naught value. So now you can understand how big the calculation is going. That's why I'm telling, take the approximate calculation and try to practice each and every calculation quickly. The same thing, what is the time lag between the current maximum and the voltage maximum? So here they are asking, see here, so here they are asking the time lag. So first of all, you have to find the phase difference between voltage and current. That is XC by R. See, generally in these situations, if it comes like exact value, then only we can find. Otherwise, in the examination, they have to mention what is the required value. Because suppose tan pi equal to root 3 came, then pi is 60 degrees. Nothing but pi by 3 radian. Because pi value we have to take in terms of radian. So that we can understand. But it came something like 0.3, 0.5, something random value, then we cannot get the tan pi value. So then in that cases, they have to mention or they will mention in the question. So after finding pi, then what you have to do is the relation between phase difference and time difference, that is 2 pi by t into delta t or omega delta t. Then delta t is time lag between 2 points which are having phase difference delta pi, that equal to delta pi by omega. So after finding phase difference, then you can substitute here and you can calculate it. But here the main thing is, if tan pi is not coming the regular values like tan 60, tan 30, tan 45, then they have to mention and they will mention in the question. Accordingly, you can use the data. Now, the next question is, if the reading of voltmeter V1 is 30 volt, what is the reading of voltmeter V2? See here, the AC source they are given like this. That means V0 value is 40 root 2. Now, as it is LCR series circuit, so across this, the resultant will become VL minus VC or VC minus VL, that they have given as V1. Now, V0 square will become V1 square plus V2 square. Now, if the reading of voltmeter V1, that means VL minus VC they have given, that is how much, 30. So that V0 is 40 root 2 whole square, and this they have given as 30 square plus V2 square. So that V2 square will become 40 root 2 whole square means 3200 minus 900. Yeah, 40 square means 1600 times 2, 3200 minus, okay. Then 2700. 2300. So if you square, if you remove square, square root will come. So 10 root 23. So root 23 means it is the approximate value is 4.9 or 8, 4.8 approximately it will come. Now the next question is find the voltage across the various elements, that is resistance, capacitance and inductance, which are in series and having the values respectively given EMF as. So it's really very lengthy question only just because of calculation, because here V naught value they have given as 100 root 2. Then first you have to find it as I naught, where I naught is V naught by Z, where Z equal to under root R square given plus omega L minus 1 by omega C whole square, where L and C given and omega value is T coefficient nothing but 1000. So once you get the impedance, then you can get I naught. Then after getting I naught value something, then the voltage across resistance is I naught R, voltage across capacitance is I naught XC, and voltage across inductor is I naught XL. So these many calculations are included here. So practice these calculations twice and thrice. So how perfectly, how fast you can do the calculation, that is better for your performance and that helps you in saving the time in the examination hall. So these kind of calculations you have to do twice and thrice always. Please try to do the calculation. Now one last and final question. A box P and a coil Q are connected in series with an AC source of variable frequency. Now the EMF of the source is constant at 28 volt. The frequency is so adjusted that the maximum current flows in P and Q. Find impedance of P and Q at this frequency. Now here, if you look at the circuit, it's like series LCR only. L, C and two resistors are there. Then the resultant resistance you can take it like R1 plus R2. How much? 28 ohm. But the very first thing what you have to do here is, they are telling that the maximum current. So maximum current means, see, maximum current implies resonance condition. So resonance condition means XL equal to XC, nothing but omega equal to 1 by root LC. Then you will get the frequency value omega. So after getting that, then I naught maximum value will become V naught by Z, and Z will become minimum, that is nothing but resistance. Then you will get the I naught value. Now you find the impedance of each of the circuit. So impedance of P means under root R1 square plus XC square. And impedance of Q if you take under root R2 square plus XL square. Now voltage across P and Q means, voltage across P means I naught into ZP. Voltage across Q means I naught into ZQ. See, here they might have asked 2-3 questions, but generally in the entrance, they'll ask either any of the question. So you need to understand what is the data given and what are the formulas we can use. Accordingly, you can solve. But here, one thing you should understand that whenever the current is getting maximum, that means resonance condition, then you can apply the resonance condition formula. You can find the resonance frequency, and that time the impedance of the circuit will become minimum. Accordingly, you can calculate it. So this is how you need to solve it. So please take care of calculation. In this question, the difficult part is ZP and ZQ. The impedance of the box P and the impedance of the box Q. So this is how always it related to big calculation and purely based on the formulas. understand the question and take the proper relation and collect the data and try to do the careful calculation. So similar kind of questions I have given as assignment. So please try to solve all the questions. Like here, 3 questions are there in one question. So it will become like a practice for you. And even in NCRT also a lot of questions they have given. See here, see 7 questions are there. So a lot of questions they have given. So you can understand the importance of LCR series circuit, which is even important for board examination also. So class 12 board examination also, this is one of the very important topic. So practice all the questions. So thank you all of you. Will continue in the next class with the next question. Thank you.